Hello everyone, welcome to the conference and my talk on CloudStack locking service. I'm a software developer with ShapeBlue, and I've joined ShapeBlue at the start of this year and started working on CloudStack maybe around late last year. So I'm relatively quite new to the product and software project. And previously I was working on application development domain, and this is my shift to infrastructure, and I'm really grateful to the welcoming community that we have with CloudStack. So this is my first time attending the conference, so if things don't go right with this presentation, my apologies with it. A little about me. I am from India, and I have worked on some of the features on CloudStack recently, like domain zone specific offerings, VM ingestion, which is yet to be merged with the master, and container service plugin, which is also in works. I love working out in gym, watching action movies, discussing political things with friends. So that's me. Objective of this talk is to start a discussion around a new locking service manager and plugin interface for CloudStack with one of the distributed locking managers such as Zookeeper, Hazelcast, or anything else. Outcome of which can be having a CloudStack database with multi-master read-write and HA and load balancing capabilities. We can also implement peer discovery using some of these locking managers, and with the help of it, we can get rid of some of the things like mshost table in our database and have a better peer discovery. Why do we need a locking service in CloudStack? So, as we know, CloudStack can handle a number of hosts with HA capability, and with it, lots of virtual machines. It can manage multiple management servers and do load balancing there. But for database, there is limited support with only master slave configuration, and load balancing is not inbuilt. We have to set some of the DB properties and manage some of the global settings in the management server to support that. Also with this, having a active or active passive configuration for management server becomes difficult. Obviously there is no support for peer discovery as such through, because we right now what we have is database locking directly, so we can't implement with the current approach. Since our current implementation doesn't work with some of the clustering solutions such as percona, xtradb, or other clustering database clustering solutions, we can't have support for some of the things which these solutions provide. These are some of the topics that we will be looking into. So to start with a bit of introduction of locking, database locking, and what we have implemented in our current code. We will look into distributed locks, some introduction about it, different distributed lock managers. Since I have made some progress, did some demo with Apache, Zookeeper, and Hazelcast, we would look a bit of overview of that. There is a short demo of my implementation. We can see some of the comparison with my implementation and current implementation of locking in CloudStack, and maybe discuss about future work or future implementation, how we go about it. So let's get into it. Locks, or mutex or semaphores in general, when we talk about in programming, they are means to synchronize the access for some shared resource. So in my context, this is database for CloudStack. We can have multiple management servers running, which are trying to have access for a single database. So we need some mechanism how these different management servers will interact with that particular database or table or record. So as it is mentioned here, it can locks can be of two types broadly: advisory or mandatory. There is a concept of granularity. The amount of data that is being logged by an implementation is called granularity. It can be fine or coarse depending upon the amount which it is logging. Although logs are great because they help us in synchronizing the access to a shared resource, but there is certain amount of overhead in terms of implementation, in terms of debugging or writing the code itself. There are some other problems like contention, where multiple processes or nodes are trying to have access to same resource, and locking implementation is preventing them and creating a waiting time for them. There can be also a situation of deadlock where two or more processes are trying to have control of some shared resource, but due to their interdependence, it is creating blocking. Let's get into database logs. Why do we need database logs? Similar to what I said in logs in general, database logs are needed to maintain the consistency of database, ensure transaction is synchronized when multiple nodes are trying to make changes to a particular record. Database logs can be of two types broadly: pessimistic or optimistic, where pessimistic is when record is logged until a node is done with what it is trying to do, while optimistic can be where a system keeps a copy for each of the nodes and verifies later when it releases the lock. Granularity here can be on database level, like whole database is logged when multiple processes are trying to access it at file level, table level, and as you can see, row or column level. Similar issues with database logs as well. Log contention. Multiple processes are trying to have log on some record or table for shorter amount of time, but it is leading to a single lane glitch kind of situation. This can be seen when let's say a number of virtual machines are simultaneously deployed, so all of them are trying to make certain parts of database log. So eventually things become serial in practice. Long-term blocking is another issue. Multiple nodes are trying to have locks on database for long period of time, but because since first or any process is already logged the database, it is creating a long-term blocking for other processes. This can be seen due to some situation while deploying a virtual machine, it is logged some part of database, but garbage collection process is not being able to acquire the lock because it is already logged by the deployment. Similarly, there can be database deadlock. Two different actions are making a database transaction, but because they are interdependence, both of them cannot have lock on certain thing, and it is leading to deadlock. There are other issues like overhead of implementing database logs, difficult to debug because logging is something depends upon time and the actions a process is trying to make, so it becomes difficult in practice to replicate the same situation. There can be also a situation like priority inversion, where user in terms of CloudStack, user is trying to deploy a virtual machine, but lock is held by a garbage collection process, so it creates a priority inversion kind of thing because we consider deployment more in priority, so this situation can also be there. There can also be a situation like convoying where all threads have some wait time, but due to because one process is already logged the database and it is descheduled, so it is creating blocking for other threads. Let's look into how current implementation of locking works in CloudStack. Currently, CloudStack uses mysql lock functions for locking the database, particularly getLock function to have some locks with particular names on particular records or tables. So basically, it's locking the database itself. It keeps a hash map of created acquired locks, and code handles them thereby. A feature of it can be said that it is fast and effective because we are directly locking the database, so there is no such server or third-party interaction between the process and database like what we will have with a distributed locking manager. Limitation of current design is it cannot work with clustering solutions. As I mentioned, something like percona xtradb won't work because it doesn't support some of the functions that we use in our logging implementation, that is get lock, release lock, and we cannot have multi-master DB where all of the nodes are trying to make some transaction. And for high availability also we have limited support with setting it through DB properties and making global settings work. So here comes the concept of distributed locking, which can solve some of these problems. Now let's look into distributed locks. Similar to normal locks, distributed locks tries to synchronize the access for shared resource when application is deployed across distributed systems. So it creates a coordination between different nodes. Like if we have multi management server set up for our CloudStack deployment, it will create a locking synchronization between them. Some of the features for a locking, distributed locking can be, there will be only one server which will write to database at a time. There cannot be multiple accesses at the same time. So there will be some concept of leader selection or master selection there. Let's look into distributed locking implementation. It is a bit complex as everything we have in distributed systems, because apart from normal variables, there are also situations of network failures, different nodes failing at different times. So it creates complexity further. For implementation, we have already some of the algorithms which have been proposed, such as Redis, Paxos, etc., which implement some known distributed locking managers such as Zookeeper, Hazelcast, Google's Chubby, etc. For distributed locking manager, there can be different modes as mentioned here: null, concurrent read, concurrent write, protected read. Here's a table which shows how these different modes work with each other. So as can be seen here, protected read or write won't work with concurrent read write. It would work with concurrent read because there's only read happening. So with this table we can see how different modes work. There are a number of existing distributed locking managers. There is Apache Zookeeper. It is a high performance coordination service which also provides locking mechanism. There is Redis, Hazelcast, Chubby, etcd, console. We can also use gRPC, etc. Let's see Apache Zookeeper. As it is from Apache, it is an open source high performance coordination service. It also provides locking, distributed locking implementation. So some of the stuffs which it provides helps that developers don't have to write them themselves. It can be, since it is open source, it can be modified to specific needs. So many companies use it, such as Netflix and all. There's a Java client library from developed for it called Curator. Basically, it performs through this concept where a Zookeeper setup is deployed on all the distributed nodes, and with the help of its implementation, it selects a leader among them, and that leader is responsible for making all the requests which we give, irrespective of from which server it is coming from. For implementing it in code, it is quite simple. We can In our management server, we can implement it through an embedded design. We can start a Zookeeper server, and to connect to this server, we can create an instance of Curator client and perform our locking through it. As it can be seen here, there are interprocess lock, mutex lock classes which can help giving distributed locks with a particular name and timeout value to acquire and lock. There's also Hazelcast. This is an in-memory solution, so it is comparatively faster than what we get in Zookeeper. So it has a distributed version of some of the data structures which we have in Java, such as maps, set, lock itself. So it works quite well. Similar to what we have for Zookeeper, we can create a Hazelcast instance in our management server code for implementation. There is a concept called CP subsystem which we need to create for Hazelcast implementation, and create some instances for it, and locks can be acquired through this instance. So for implementing locking servers in CloudStack, what I did for my demo is I created a pluggable design where there will be a generic lock manager, and different plugins can be implemented for it based on user requirements. Like I created a demo with Zookeeper and Hazelcast. Others can use something like Redis or Chubby or anything else, what they feel like. We can have a global setting with any name, and different value can be set to it for using different locking manager. Okay, so currently in this demo, I'm using my CloudMonkey based CloudStack deployment, and it is currently using the default mechanism for database locks what we have in CloudStack. So I've implemented this logging where it shows what lock it is creating, and the time it takes to acquire a lock in milliseconds. So with default implementation, as it can be seen, the times are something in like 2 milliseconds, 1 milliseconds, etc. As it can be seen, I've created this global setting which I can use to set the locking manager, and it can change the locking in CloudStack. Currently, I am trying to use Zookeeper implementation. What I did. So I restarted my management server. Okay, so if you guys can see, since Zookeeper will work on an embedded server client architecture, the locking times for acquiring a lock have increased to a large extent compared to default mechanism. As you can see here, it is taking somewhere around 14 milliseconds, 9 milliseconds. Now since it was taking a considerable large amount of time compared to default mechanism, I also tested it with my Hazelcast implementation. As it can be seen here, Hazelcast creates a number of nodes and instances for creating the locking. So in my experience, it took more time to start a management server than what we currently have, or what we have with Zookeeper. So after a while it starts. So here the time to acquire a lock have reduced compared to what we have with Zookeeper, like it is 5 milliseconds for considerably less, but more than what we have compared to default implementation. This was expected, as in Hazelcast Hazelcast also they will be there will be a server through which our locks will be acquired, so time will be more. Why I chose generic framework for implementing a logging service? It is always better to have choices. We have choices of different hypervisors in CloudStack, so why not for having a logging service? It becomes easier to develop because different developers can have different implementation, and they can develop on their preference. As it is seen, there is also performance difference when we looked into Hazelcast and Zookeeper. So different users can use different locking service, maybe the default one itself. So this is a graph citing the lock acquire time during VM deployment. So as the light blue color shows current implementation, where we have DB database locking itself, which is less than 2 milliseconds. For Zookeeper, the times have increased considerably, while Hazelcast performs similar to what we have with default implementation, sometimes more, sometimes less. There are also issues with distributed locking, which we have something like firstly we have to make the implementation, and then have optimizations over it. So I don't know how we are going to proceed, but it would be good to have a locking service to support MySQL clustering solutions. Future work can be like currently I have a basic implementation of Hazelcast and Zookeeper, so I will be trying to create a discussion around it on mailing list after this conference, and we need to test it with clustering solutions. I tested with Percona xtradb, but we need more testing. After we might decide we will be implementing only a particular distributed locking manager, not the generic thing. So optimizing that would be first thing. We can, in my opinion, we can target something like 4.15 version of CloudStack for having a locking service, if not 4.14. So I'm looking forward to it. Thank you. Any questions or thoughts around it? Yeah.
How are the locking services defined in CloudStack? Like, are they just a part of the code base and hard coded, or are they discovered, or
With my implementation or existing one?
with the proposed implementation?
I propose a framework kind of design like we have for something like different hypervisors or storage solutions. So it will be a service manager impl kind of thing where different plugins can be made depending on different locking managers. Like if I show. We can have a interface for DB locking manager, and based on that we can implement our different plugins, something like Zookeeper manager impl or Hazelcast manager impl, like sorry. Like here I implemented a Zookeeper DB locking service, so it implements DB locking service and it gives a name here, Zookeeper. So same thing can be mentioned in global settings, and based on it code will discover it based on its bean. And if I show like this is Zookeeper base, I can add here a Hazelcast based locking service. So does it? Anything else?
When you say locking, there are some different perspectives when you are doing that in a database. For instance, when we do that using Java applications in the code, in a sense, here we want to do that, not actually because we want to lock, but normally because we want to go back to the So what's the problem that we solve deploy that uses deploy children once?
Not really. Like we already have code for it, which implements locking while doing this. So thing is, we cannot have database clustering right now. So
Yes, that I do understand. You are saying that the problem with the locking system right now is just about the application database. But my question is, I think we should do a step backwards. Do we need that kind of locking? Or what's the problem with perfect? So, because for instance, actually the problem is not speed like you were measuring.
yeah,
Because I just trying to avoid that it's the plot two things at once at incredible speed. The problem is actually the deadlocks.
yeah,
Those are the problems for perfect scope. And one of the issues that I have checked in the past in CloudStack that, for instance, people are executing locks when they are not needed. Like when you are listing just some interest in data, you don't need to apply locks there. And that creates deadlocks when you try to, the same user is listing and deploying at the same time, which should happen. And so that's why I think.
yes. I think that is one technical that we had with current code. There are a lot of places where we are implementing locks where we don't actually need them. So that can be also looked into while doing this exercise. We can maybe refactor the code for it. But my proposal was only relating to implement something for database clustering here. Thinking about like, do we really need locks is a different thing altogether. So
Because actually, even though it's a different thing, it solves the same problem.
yeah,
Because if we don't need locks, we can solve the database problem without adding another software to the stack. That's really my point.
yes, but it would be like, in my opinion, it would be difficult to remove the locks altogether. Like at certain situations, we will actually need them. Like while performing a VM deployment, we need to lock certain tables or records in the database. So it would be hard if we remove the locking it as a whole. Yeah.
We could send jobs to the skill, and then depending on how we read the skill, we can do all those things without blocking the database. That's why I'm questioning, because it might be interesting for CloudStack, to take a step back and think about how it needs this kind of blocks that it needs right now. Because either way, if we are going to remove the locks, or if we are going to adopt some which are proposing, the change in the database that we have seen is huge. It's a million times database, and when whatever you try to implement it, the impact in the database and the code base is going to be pretty significant. That's why it would be a good idea to take a step back to investigate what kind of blocks we need and when we need them, and what kind of methods we can use to address this kind of needs that we have for new blocking system. And it might be so with different approaches, not just with blocking system, but really with messaging system. And then we can
Yes, surely. So one point of not having a proper demo or proper implementation was this as well. Like to start a discussion, maybe this is my solution, but other members in community have a better or different solution altogether. So this is one thing. I really support, like we can have a discussion on mailing list and maybe I start a thread, like as you mentioned, a different approach for taking a look at this problem. Anything else?
Yeah, question. So you have not, the system already hatched was with one database server, or is it multiple database servers?
This test was only on one database server right now, the demo which I was showing. Okay, thank you all.